Welcome back to my channel Rajguru Chemistry. Today in this video we are going to discuss the topic of electrochemistry, conductometric titration, acid-base titration in case of strong acid versus weak base. Acid-base titration, strong acid, strong base and weak acid, strong base, mixture of acid versus strong base. These topics we have already seen in the previous video. Now let us come to the practical session. Strong acid versus weak base. Taken the example of hydrochloric acid is strong acid and ammonium hydroxide is a weak base. The reaction is hydrochloric acid is treated with ammonium hydroxide gives ammonium chloride and water. Hydrochloric acid is an analyte and ammonium hydroxide is titrant which is taken in the burette. Hydrochloric acid is a strong acid. It will be easily dissociated, so it is represented as ions. Ammonium hydroxide is weak base. It does not dissociate immediately, so it cannot be represented as ions. Ammonium chloride is a strong electrolyte. It will be easily dissociate. It will be represented as ions. Water molecule does not contribute in the conductance. Now let us come to the practical session. Strong acid versus weak base. The aim is to determine the strength of given hydrochloric acid by conductometric titration. Requirements for this experiment: hydrochloric acid, ammonium hydroxide, burette, pipette and beaker, glass rod, then conductivity meter with a cell. Now we go to the procedure. The given hydrochloric acid is transferred into a 100 ml standard flask and made up to the work using distilled water. 20 ml of this solution is pipetted out into a clean 100 ml beaker, added 30 ml of conductivity water so that the conductivity cell is completely immersed in the solution. Conductivity cell consists of two platinum electrodes in which one of the electrode acts as an anode, another acts as a cathode. Ammonium hydroxide solution of strength 0.5 N is added in 0.5 ml portion from the burette to the solution. This solution is stirred well and allowed to attain equilibrium. Then see the conductivity of the solution between two electrodes because of the movement of positively and negatively ions of the opposite electrodes. It shows conductance. The conductance is mainly due to the H+ ions which have very high mobility. As alkali is added, the H+ ions are removed as feebly ionized water molecules. The conductivity of the solutions decreases due to the replacement of H+ ions by slow moving NH4+ ions. Once the endpoint is reached, after the neutralization, there will be no change in the conductance value. It is totally constant. The conductance is noted and it is plotted versus the volume of ammonium hydroxide added from the burette. The point of intersection of two lines gives the endpoint. This is the volume of ammonium hydroxide for the complete neutralization of HCl. The reaction is given below. Then we come to the calculation. The strength of ammonium hydroxide is 0.5 N and volume of ammonium hydroxide is got from the graph and volume of hydrochloric acid is 20 ml. From this value we can calculate the strength of hydrochloric acid. The model graph is given below. This is the conductance value. Here the volume of ammonium hydroxide. The intersection of two lines we get the volume of ammonium hydroxide to the complete neutralization of HCl. Then finally we can calculate the strength of given hydrochloric acid present in the solution. I hope you like this video. Share the video with your friends. Do subscribe the channel. Click the bell icon to get more notification. Thank you.